So in this example, we want to be able to compare two function values. Before we do that, let's look at this picture that I have up here on the screen. The first triangle is a right triangle. You can see it has, we're talking about angle A, and if I wanted to take the sine of angle A, then I would be looking at the ratio of y over r. Okay, so here I have angle A and I have y represented with this red line. Now notice in the second triangle I've made the angle A larger. So as the measure of angle A got larger, the length of y gets larger. And in this third triangle, angle A, the measure of angle A is still larger, so it's increasing here, and you notice then that the length of y is getting even larger. Well, what happens then to the value of y as my angle A is increasing? As A increases in each of these triangles, the length of y, or the value of y, was also increasing. And what effect is that going to have to my ratio of y over r? So if I'm looking at y, let me get my pen going here. If I'm looking at y over r, and I know that as A increases, let's put that over here, as my angle increases, y is also going to increase. Y increases. And what happened to r though? In each of these triangles, I know for a fact that my angle r, not my angle, the length of r is also going to stay the same. So r is always fixed. The hypotenuse of our triangle is always going to be fixed. So r is fixed, or it stays the same. So if y is increasing and r stays the same, that's going to make my fraction also increase. So the fraction, or the value here, is also going to increase, or it will get larger. You can kind of think of that by saying, okay, if I had the fraction 3/4, then I had the fraction 5/4, then I had the fraction 7/4. Okay, the denominator in each of these cases is staying the same. The numerator in each of these cases is getting larger, and that causes my value here to increase. Okay, so we can kind of summarize that by saying, as my angle increases, then the function, the trig function, will also increase. What if I wanted to keep with this concept here, and instead of talking about the sine of angle A, what if I wanted to talk about the cosine of angle A? Okay, what's going to happen to the cosine of A as my angle increases? So we want to go back and we want to look at, well, what is the ratio for the cosine? Cosine is x over r. Okay, if we're talking x over r, oops, let's go back this way. Notice what's happening to the side where x is. In each of these triangles, as my angle was increasing, x is getting shorter. Okay, so x is decreasing as r stays the same. Okay, so if my numerator is getting smaller but the denominator stays the same, then my fraction is actually decreasing. Again, let's try it this way. If I said 3/4, 2/4, and 1/4, you can see that my numerator is getting smaller, and therefore my fraction is getting smaller. So for this case, when we talk about the cosine of angle A, as the angle increases, the function decreases. Okay, so let's use that idea to be able to compare two things in this example right here. So let's look at this example right here where we're being asked to determine whether a statement is true or false. In other words, is the tangent of 25 less than the tangent of 23? Well, we want to start by going back to the ratio for tangent. Tangent would be y over x, right? And as my angle is increasing, okay, as my angle is increasing, we want to determine what's happening to the y values and what's happening to the x values. So you can go back and kind of picture that triangles, those series of triangles that we were looking at. For my y values, as the angle is getting larger, the y values were getting larger, right? So y is actually increasing, but my x values were decreasing. So the numerator in this case is getting larger and the denominator is getting smaller. So if the numerator is larger and the denominator is smaller, the overall fraction ends up being larger. Okay? If it helps for you to put some numbers in, we could say, I don't know, 7/5, 8/4, and 9/3. I can see that 9/3 would be 3, 8/4 would be 2, and this is somewhere over 1. So it's 1, 2, 3. You can see that my overall effect of the fraction is actually getting larger. So as my angle then is increasing, okay, as my angle is increasing, the value of tangent would be increasing. Let's write that down for a second. As the angle increases, the tangent of that angle, the tangent of my angle, theta, is also increasing. Okay, so this statement right here, to say that the tangent of 25 is less than 23, would be false. So that's false. Okay, let's look at that again because this is kind of an abstract concept. Let's go with cosecant this time. For cosecant, I know that cosecant's ratio would be r over y. Okay, so I've got to put it in terms of its ratio. And I know that as my angle is increasing, r is going to stay the same. So it's fixed. It doesn't move. It doesn't change, actually. And as my angle is increasing, y is also increasing. So what effect does that have on this value, on this fraction? If the numerator stays the same and the denominator consistently gets larger, then this overall fraction gets smaller, or in other words, it decreases. So as the angle increases, the function value decreases. Okay? So as my angle is getting larger, as it moved from 40 to 45, this becomes then, this is a true statement, right? So 44, the cosecant of 44 would really be less than the cosecant of 40 because the function value of cosecant 44 is less than the cosecant of 40. So this would be true.